The students assigned to reverse engineer the Revlon 1875 watt hair dryer. And basically our hair dryer operated on two main settings, which was a high setting and a low setting. What the high setting allowed the dryer to do was to blow warm air at a high rate of speed, and the low setting allowed the hair dryer to blow warm air at a low rate of speed. There was also another feature, which was the cold shot button. What the cold shot did was allow the hot air to stop blowing, so it would blow cooler, room temperature air at you. So if it was getting too warm to the touch or anything, you could just push the cold shot button and that would fix your problem. Another one of our features was the removable air filter, which allowed you to take the back off of the hair dryer and you could clean it. So if it was getting too dirty or if you just felt like you wanted to clean it, then you could do so. And then lastly, some of the features of our hair dryer was that it was lightweight, it was cheap, and it was small. So it allowed for consumers who are on the go. It was really good for them. It would allow them to travel, or for like ladies who would just for some reason need a hair dryer, they could put it in their purse because it was small. So it made it easy and usable for all consumers.
This is low setting? And then if you use cold shot, it goes like this.
Okay, this is our hair dryer and this is how it's kept together. Basically there are two screws on the back that are inserted to keep the two different pieces together. And then there's a little wedge on the top to also keep them together. And then there are these gray things between the two parts. Mainly they're just for decoration. And these are the wires, and there's a spring right above the cold shot. This is basically the parts of the hair dryer. You have the head and the handle, and then inside there's a fan, the coils, the back to separate large chunks of hair or dirt getting in there. And this is the fan. Basically it spins very rapidly. It's powered by the electricity. And here's the coils. Basically electrons move around them really fast, creating a lot of heat. The fan blows through the heat, creating the warm air flow. It's held together by installation paper. And here's another piece of installation paper. It is wrapped around the coils so that it doesn't overheat from the outside. Screws down. I did the two screws. Now there's a little wedge keeping this together. Okay. What's this? It's a screw. And this is a fan. And here's the circuit board. This to keep it from overheating, and the same material is used to support these coils. Wrap around. There's the resistors right here. See that?
During our reverse engineering project, we decided to find out how the button works. In the buttons, I mean by the high speed setting, the low speed setting, as well as the cold shot. So when we were opening the hair dryer, we noticed there were a total of 6 wires in there. There were 2 red wires, 1 yellow wire, 1 blue wire, 1 purple wire, and 1 gray wire. Now, for the high speed setting, we noticed there were 3 wires connected to it. There was a red wire over here, there was a purple wire, and then there was a blue wire. We also noticed that the red wire was also connected to cold shot, but we'll explain more about that later. In the meantime, this red wire served to control the speed, the fan speed. It made the fan blow out fast, stronger air as well. As for the purple and the blue wires, these wires were connected from the high speed setting to the coils on the fan. These 2 wires serve to heat up the coils so that it produces a warmer, hotter air. For the low speed setting, we noticed that, well, the low speed setting is right here, and we noticed that it was actually only 1 wire connected to it, which is this yellow wire right here. We determined that this yellow wire controlled the fan speed. It blew out an air that was not as fast as the high setting, but just warm enough. Okay. Yeah. Okay. For this cold shot, we noticed that there were actually 2 wires connected to it. There was a red wire here and a gray wire here. This red wire was actually the same wire that's connected to the high-speed setting as well. This red wire was responsible for maintaining the high fan speed, while the gray wire is, in a way, responsible for maintaining heat as well as taking away heat when the cold shot button is pressed. The way this cold shot button works is that it is actually a physical button over here, where in order for it to work, we had to physically press the button. When we press the button, this would cause this white compartment to move backwards. And in effect, it would also come off of the gray wire. As in this case, then the gray wire is turned off, which means that somehow the heat is then taken away from the system. When the button is pressed back, it also turns on the red wire, which then turns on the high fan speed. Now the last red wire that we found actually serves as a safety feature, in that in one side it connects to this plastic material, which is actually storing the current and like transporting it. On the other hand, it's connected to a resistor, which is actually on the coil itself. Now, for example, whenever the hairdryer were to like fall into a puddle of water or to a tub of water, then it would automatically trigger this thing, which would then blow the circuit. And when it blows this circuit, this part would be unable to transfer energy, the current back through the rest of the hairdryer, therefore cutting off power to the hairdryer.
Hi, I'm Ailey Buper, and to get a better grasp on the power of our hairdryer, we decided to compare it to the Conair IonShine 1875-watt hairdryer. And one of the main differences between our hairdryer and the Conair was that it actually had 3 heat settings: a cold, warm heat, and a high heat, as well as 2 different fan settings, low and high. Also from this picture, you can see that the Conair was slightly bigger than our Revlon, and it was also in a higher price bracket, priced around $20 as compared to the $10 of the Revlon. So our experiment consisted of taking a standard Room Essential brand bath towel from Target. We folded it in half, and then taking one of these cups that they gave out during new student orientation, we filled the cup up to like a quarter full and poured water on each end of the towel. We then held each hairdryer respectively over each little pool of water for 10 minutes. At the end of 10 minutes, we looked at each spot, and as you can tell from these pictures, this was the Conair IonShine, and you can see the area right here where the water used to be, but you can tell that it's not as dark when you compare it to the Revlon, which you can still see that there's some water left over. So we concluded that the Revlon's fan power was significantly less than.
Some of our design trade-offs was that it was manufactured cheap, and so it couldn't have that many features. One of the things that could have been changed if it was more expensive is you could have more settings. So like with the temperature, for example, all you could have was a warm shot or a cold shot. There's only 2 temperatures, and the cold shot only worked on high speed, so you couldn't get cool air at a low speed. And also, with the 2 settings, the high and the low, if you wanted a setting in between so you get hair to dry different, like at a different speed for some reason, then you couldn't do it because there's only a high speed and low speed, so you can't dry things very differently. And then another trade-off that was there was that there's insulation paper in this part of the fan that we discovered when we took it apart, but not in the front part. So when it's blowing, if you like touch the front part for some reason, it'd be really hot to the touch the longer it blows, because it just didn't have any insulation paper to keep that plastic from getting hot. So this part would stay cool, which is where all the wires and circuitry was. So that's a good thing, because it would, the wires wouldn't overheat, that wouldn't melt on the inside. But you don't want to burn your hand when you touch the. The manufacturers wanted the hairdryer to be cheap. They couldn't use any different materials. They chose to go with plastic because it's pretty cheap and affordable. But it couldn't use a durable material such as like stainless steel. There are some hairdryers that you can buy that are stainless steel, and they'll of course last longer and they're more durable. They won't bend as easily and they won't crack or break as easily. But since it's cheap and manufactured, you can just buy another one because they're so inexpensive.